All right, everybody, welcome back to What Do You Know? So I need to break that down. I need to break that one down. Because that's a lot going on here. Initially, right, we start off at 23 degrees Celsius. I want to put a 23 here. That's my C. So we at 23 degrees Celsius, and what they're gonna do, they're gonna heat me up. Bam. So I started to get heated. And then bam, this little mark right here is where I hit my boiling point. And on this particular reaction, we're actually going to stop at 78.3 Celsius. So we're looking at the heating curve right now, right? Because we started off at 23 degrees Celsius and we're going up to 78.3 degrees Celsius, right? As we go up, the temperature is increasing. And as we go further towards the right, we need more energy, right? So this is going to be in joules, kilojoules right here. So as we go up, our temperature's going up, bam, but also we're going to need more energy as we continue to heat this up, right? More heat, more energy. Now we got 50 grams of ethanol, and we see that our 23 degrees Celsius is going to go up to 78.3 degrees, 78.3 degrees Celsius there. So the two steps that I'm paying attention to is that we're heating it up, heating the liquid up, and then once we heat it up, we actually reach the boiling point. Okay, so that's a key step. That's a key step because the fact that we reach the boiling point, that's going to let me know, okay, hold on. Now that I reached the boiling point, we're going from a liquid to a gas. Okay, in this case, that's 78.3 degrees Celsius. So because we actually have a phase change here, we're going to need the enthalpy of vaporization, which they happen to give to us. Look at that question. Really look at this question, right? Because this is a heating curve type of question. So you always want to pay attention to your steps. I want to focus on that very first step because we're going from heating the liquid to the boiling point. That's where we're going, right? So anytime that we're actually heating the liquid, in that case, right, if we're going to a point, we're going to use specific heat equation. Now, who remembers that equation? Q, right? That's all we're talking about is heat. So Q equals what is it? All right, did y'all remember? Okay, cool. All right, if not, let me give it to you. M for mass, CS for specific heat capacity. And then of course we got the delta T. Okay, we got the delta T for temperature. Now, if y'all forgot about delta, then that's just basically in the chemistry world, that's the change in temperature. So we're talking about change in temperature right here. Now, because we're looking for the heat, so we know our M, that's 50 grams. That's what we got here. Big 50. The 0 is a little bigger than a 5 right here. What about our CS? CS stands for specific heat capacity. Now, what was the specific heat capacity of ethanol again? That was 2.46. Pay attention to units right here. Joules over grams Celsius. Pay attention to those units right there. All right, so bam, we got our CS, our specific heat capacity. And then what about our delta T, everybody? What we got for delta T? Delta T, right, is going to be what? Remember, we're talking about the change in temperature. So anytime we talk about change in something, right, you're going to have your final condition minus your initial condition. So in this case, our final condition, right, our final temp is 78.3 Celsius, right? That's what we're ending with. And our initial, what do we start with, everybody? 23 degrees Celsius, okay? All right, so 78.3 minus 23 is going to be 55.3. And once again, everybody, I don't have the units included right now. I'm just focusing on the numbers. I like to look at the numbers in the units. So 50 times 2.46 times 55.3. What is that going to give me? 6,801.9 to be exact. You know, I'm just going to say 6801. All right, that's what we're going to give myself with here. And now that I know the number, let's go back to the units here. Let's go back to the units. let's just call this what it is, 55.3 Celsius. That's what this number is right here. So when we look at the units though, what are we going to see that's going to be key here, everybody? What happens to my grams? My grams are going to what? Cancel out. Bam. Grams gone. Bam. Got that out the way. Okay, cool. But when we also multiply, what's going to happen here, right? Celsius. The Celsius is on the bottom in my middle unit. And we're multiplying what? The change in temperature. And in this case, right, pay attention, the Celsius is going to cancel out with my what? 55.3 Celsius. Bam, the Celsius is gone. My grams is gone. And then what am I left with? I'm only left with joules. Okay. So because I'm only left with joules, bam, what is my unit going to be? 6801 joules, 6,801 joules. Okay. Another hint is that if it's asking for heat, Q, you know it got to be in joules. It has to be in joules because we talk about energy. Heat is energy. Energy is heat. It's all one thing here. Okay. All right. So now that we got our first step down, okay, so let's go back. Go back to this little diagram here, right? I know that the amount of energy that's taken, right, that's happening right here, 6801. All right, that's how much is happening right here, going from bam, bam. But what about this process? This process right here, right? This little process right here that's going on, right? The liquid, the amount of energy it's going to take to actually go from a liquid to a gas with however long it's going to be, we got to figure that out, right? So this little step right here, we call this step enthalpy of vaporization. Now, how are we going to figure out that step? Well, let's go. So what I'm going to do here is that I'm going to have to use my enthalpy of vaporization. In this case, it was 39.3 kilojoules per mole. That's fat for our ethanol, okay? Now, couple of different things, right? Enthalpy of vaporization, we understand that that's going to be ending with our unit kilojoules. Okay, enthalpy of vaporization. Please remember, right? Anything with heat, enthalpy is probably going to be ending with kilojoules, joules, something with the energy unit. Okay, so we're going to take our 50 grams of our ethanol, C2H5. OH, and we're going to do some basic conversion right now, some dimensional analysis. Now, of course, in chemistry, dimensional analysis never goes away. Of course, right? So, let me see here. We're going to go from grams to moles. Now, let's do this right as a quick reminder, grams to moles. You know, if you haven't looked at my previous videos, I highly recommend. I'll focus on my units first. That's the technique I like to use. Bam, my grams cancel out. What am I left with? Moles, right? So I'm going to be left with moles. And now let's worry about the numbers. So we got to understand that this step here, we're going to use a molar mass step to convert your grams to moles. Now the molar mass is telling me that I got a certain amount of grams for every 1 mole. Okay, so in this case, that 1 mole is our ethanol. 1 mole of C2H5OH, right? That's my whole unit. I didn't put the C2H5OH to just now. And then, of course, the grams is going to be the grams of the C2H5OH ethanol. Now, how many grams, right, when we talk about molar mass, how many grams are in this 1 mole? Now, quick reminder, how do we even find the molar mass, Dr. J? I don't even know what you're talking about. So, molar mass, how do you find the molar mass? This is just a quick reminder. Look towards our periodic table. Look towards the periodic table. And what we're going to do here is we're going to add the mass of our carbons. So, we remember carbons is at 12. So, I got 2 carbons times 12. Hydrogen, right, is 1. So, that's going to be our 5 hydrogens here. C2H5. I'm going to add up my 1 oxygen, 16. Where are we getting these numbers from? Periodic table, just a reminder. And then our hydrogen, we got 1 more hydrogen, that's 1. So when we add up all of our masses here, we're going to see that I got 46.07 if I want to get technical, right? So from here, right, I can convert this to moles. Now I'm about to add this all in one go just to show everybody. But right now I'm in moles of C2H5OH, right? Because my grams are canceled out. So I'm in moles of C2H5OH, ethanol. Now, how can I use this moles to my benefit here? What can we do? We could still convert something. I can actually go from moles to kilojoules. Now, we could use that enthalpy of vaporization to actually cancel out some moles here. Bam. And then what is enthalpy of vaporization? Right, kilojoules per mole. So the enthalpy of vaporization, kilojoules per mole. And if we're talking about ethanol here, right, C2H5OH kilojoules. So we know that that's going to be ethanol right here. And then we mentioned that the enthalpy of vaporization for this one is 39.3 kilojoules per mole. And what we see here happening is the moles cancel out, and then we left with kilojoules, right? So all these units are canceling out to what we left with, kilojoules. Now I can just what? Multiply to get my final answer. Real simple, real simple. I just multiply across and then I divide. 2 steps. I can do this every single time. So when I say multiply across and divide at the very end, I'm talking about I'm just going to multiply my 50 times my 39.3, right? 50. Shout out to 50 Cent. Okay, so 50 times 39.3 divided by 46.07, right, as my denominator. So essentially I multiply across. So I'm going to multiply all my numerators across, right? Boy, I'm giving y'all a mini lesson in dimensional analysis right now. So this is my numerator, denominator on the bottom, right? We understand this over 1. So 50 times 1, right? I didn't put it over here, but 50 times 1 times 39.3, right? That's going to give me my top answer. Then on the bottom, we're going to do the exact same thing. So 1 times 46.07 times 1 is just 46.07, right? Now, what can we do? Now, I can multiply across, and what's that going to give me? That's going to give me 1965. Hey, 1965. All right, so, and then we got 46.07, so that's staying the same. Now we just got to do what? Divide the numerator by the denominator. And 1965 divided by 46.07 is 42.65, or we could just say 42, keep it simple, 0.7. All right. So that's what we got for the number. And then what's the units, everybody? We already found the units way back in the day, right? Earlier in the video, kilojoules. Bam. So we got for the second step 42.7 kilojoules. Bam. Now, right, we went up. It was 6,801 kilojoules. That's 6,801 joules. And then because this is kilojoules, I'm just about to convert this real fast to kilojoules. If y'all remember, that's going to be joules on bottom, kj on top. For every 1 kj, there is what? 1,000 joules. Thank you. All right, so 1,000 joules, and then that's going to be 6.8 kilojoules. All right, kilojoules. The 6.8 kilojoules came from what? This step right here, right? The specific heat equation step, the very first step, because we were heating what? We were heating that up from 23 degrees Celsius to 78.3 degrees Celsius here, right? And that took 6.8 kilojoules. That's what it took here. Now, once we got up here to the actual boiling point, it takes some energy to actually convert it from liquid to gas. And because it takes some energy, that second step, let's go to that second step, required our enthalpy of what? Vaporization, which we see right here, okay? So once we get to the second step, enthalpy of vaporization, we had to use that when we convert it to the moles here. And then we add up both steps to get to my final answer of my total energy for this entire thing. Well, it took 49.5 kilojoules in total. Let me know in the comments. Let me know in the comments if you got any questions about this one. This is a tricky one because you got to realize what you got to use. Do not let those words confuse you. You guys know this stuff for sure. You guys know this stuff. If you haven't done so already, if I'm giving value, please make sure to like the button and share this with somebody. Make sure they need help in this subject. You are telling them about this channel.